Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is 2-bromotoluene, orthobromotoluene, which has a methyl group CH3 and a bromine Br on adjacent carbons of a benzene ring. Moving on to the next step. Treatment of an aryl bromide with magnesium in dry ether forms a Grignard reagent, specifically orthotoluene magnesium bromide to methylphenylmagnesium bromide. The CBr bond is converted to CmGbr. Moving on to the next step. Protonation, hydrolysis of the Grignard reagent with aqueous acid H3O+, replaces the CmGbr bond with ACH bond, regenerating the arene. This gives toluene, methylbenzene. Wait, but step 3 involves KMNO4O, so let's reconsider the sequence. And for the final step, steps 1 and 2 together, Ng ether then H3O+, convert ArBr, ArMGbr, ArH. This means the Br is replaced by H, giving toluene, methylbenzene. Then step 3, KMNO4O oxidize the methyl group on the benzene ring. KMNO4 under basic conditions oxidize an alkyl side chain on an aromatic ring to a carboxylate, Cu-K+. Step 4, H+, acidifies the carboxylate to give the carboxylic acid, -Cu. The methyl group of toluene is oxidized by KMNO4O followed by H+ workup to give benzoic acid, benzene ring with 1 Cu group, which corresponds to option C. Option A, 2-hydroxybenzoic acid would require introduction of an OH group, which does not occur here. Option B, orthocresol would require replacement of Br with OH, which is not what Ng ether plus H3O+ does. Option D, benzene would result if the methyl group were also removed, but KMNO4 oxidation of toluene gives benzoic acid, not benzene. Therefore, the correct answer is C. Therefore, the correct answer is option C.